Okay. Yeah, hi, good afternoon, everyone. And thanks for joining us for our third webinar in our SAIMM ESG Climate Change Webinar series. Climate change is now a material consideration for the mining industry, influencing how operations are planned, financed, regulated, and managed across the full project life cycle. For mining professionals, understanding both climate change mitigation and adaptation has become essential to effective risk management and long-term resilience. This webinar series covers a set of core climate-related topics relevant to the minerals sector. Philippa Burmeister started us off with an introduction to the fundamentals of climate change mitigation and adaptation, alongside the legal, investor, and disclosure requirements that are increasingly shaping corporate decision-making. We then had Justin Mule, who examined the tools and approaches used to model future climatic changes and how these inform both physical climate risk assessments, such as heat stress, water availability, and extreme weather events. And next month, we will expand on transition risks linked to policy, technology, and market change. Today, we are exploring decarbonisation pathways, including net zero strategies, renewable energy systems, carbon offset opportunities, and the role of carbon credits. Finally, we will consider practical adaptation approaches that allow climate change planning to be embedded into mine management, supporting more resilient and sustainable operations. These webinars are intended as an introduction to topics that will be expanded in greater depth at our SIMM ESGS Conference 2026, Climate Change and Mining, to be held in Muldersdrift on the 26th and 27th August of this year. So please do reach out to us if you want to attend. And should you have any ideas for future webinar topics, reach out to the organizing committee. Both the webinar series and the conference are organized by the SAIMM Climate Change Subcommittee, part of the SIMM ESGS Committee, which welcomes nominations for new members. If you are not yet a member of the SAIMM and wish to become one, please reach out to us at membership@saimm.co.za, or you can find us online at www.saimm.co.za. So today we have Reynard Arp and James Brown. Reynard is a manager and regional lead for mining and metals at the Carbon Trust, with over 9 years experience in climate change and low carbon transition advisory. He works across the mining and metals, sustainable finance and energy sectors, supporting private and public clients on climate strategy, risk assessment, carbon footprinting, and just transition advisory. Reynard previously worked on climate policy and circular economy research at WWF South Africa and holds a master's degree in environmental economics from Rhodes University. James Brown is the CEO of Carbon Neutral Energy Systems and a renewable energy engineer specializing in the decarbonisation of the mining industry. He holds an honours degree in engineering and technology management from the University of Pretoria and is a certified renewable energy professional with the International Association of Energy Engineers. With extensive experience in techno-economic analysis, energy modeling, and diversified energy mix strategies, he supports major mining companies in South Africa to implement practical, long-term renewable energy solutions that balance near-term impact with long-term sustainability. And I'm David Viljoen, Director and Chief Sustainability Officer of CNES, and will be today's moderator. Before I hand over, please note that the presentation slot is about 30 minutes, which will give us about 15 minutes for discussion at the end. There is a Q&A feature as well as a chat, so please put your comments or questions in there, and we will read them out for James and Reynard to answer at the end. We'll also be sharing a questionnaire after the webinar, so we would really appreciate if everyone could take a moment to give feedback. And so without further ado, I'm happy to hand over to James and Reynard, who will be presenting their topic today, digging deeper how to develop a credible decarbonisation strategy. So over to you guys.
Thanks very much for joining our webinar today, and thanks very much for the introduction, David. So as David mentioned, we'll be digging deeper into how a mining company can credibly develop a decarbonisation strategy and an introduction to the mitigation hierarchy. By way of an agenda for today's webinar, I'll provide a bit of an introduction and broader context as to why the mining sector needs to decarbonize, what are some of the risks and opportunities around decarbonisation, and then provide a high-level introduction to the mitigation hierarchy. I'll then hand over to James, who will take us through each of the phases of the mitigation hierarchy in a bit more detail before I summarize some key takeaways at the end, and then we'll open up for Q&A and a bit of a discussion. So why does the mining sector need to decarbonize? Well, first, taking a step back and looking at the climate science. So the IPCC has estimated that to avoid catastrophic climate change, the global economy needs to avoid global warming of about 1.5 degrees from above pre-industrial levels. And that is an ambition that is underpinned by the Paris Agreement. As I'm sure you're all aware, we have already started feeling some of the physical impacts of climate change, particularly here at home in South Africa. Just this year, there's been significant flooding in Limpopo and in Mpumalanga. I'm sure you've seen all the videos coming out of the Kruger Park earlier this year. And of course, just this weekend, some significant storms and flooding in the Western and Eastern Cape regions as well. To date, global temperatures have already risen close to 1.5 degrees, echoing the importance of limiting global warming to 1.5 degrees. And I guess it's in this broader global context that kind of justifies why the global economy, not just mining, needs to rapidly decarbonize to maintain 1.5 degrees. Now, a lot of people ask, what is the difference between 1.5 degrees and 2 degrees? And if we're already close to 1.5 degrees, should we be aiming for a 2-degree temperature target? There's been quite a bit of research into what the difference could be between a 1.5 degree and a 2-degree world. And this slide tries to capture some of that. So on the left-hand side, there's a couple of key indicators, such as the global population exposed to severe heat every 5 years. And you can see the difference there between 1.5 and 2 degrees. So under a 2-degree future, exposure to extreme heat is about 2.5 times worse relative to a 1.5 degree temperature. I'll focus on the two at the bottom. So further declining coral reefs and declining marine fisheries, significantly worse under 2 degrees relative to a 5-degree future. And you might be thinking, well, what does this have to do with me, or what does this have to do with mining? I think important to consider that these environmental and ecosystem services underpin the global economy. So if coral reefs decline, key breeding grounds for marine fisheries disappear, and those marine fisheries will start to reduce as well. And a significant portion of the world relies on fish as a key part of their diet. So it kind of has these fundamental developmental impacts as well. And of course, if global populations exposed to extreme heat, that can exacerbate drought conditions and impact terrestrial food systems as well. So really, really critical that we try and maintain ambition at 1.5 degrees, despite the fact that we are getting close to 1.5 and might even exceed 1.5 before 2030 or 2040. So zooming in on the mining sector and why it's important for the mining sector to decarbonize. Starting in the middle of the slide, there is significant increase in demand for critical minerals due to the global energy transition. Solar panels, electric vehicles, batteries, all very metals intensive, but so too is the growing ICT sector. So data centers and AI, etc., also very metals intensive. And with that increasing demand, if we meet that demand under BAU production systems, that will inevitably increase or exacerbate existing environmental and social impacts associated with mining. Mining is already relatively carbon intensive, and if we continue with those carbon intensive production processes, then the solar panels, the wind turbines, the EVs, etc., are all going to be carbon intensive products as well. And in the end, we end up kicking the can down the road, so to speak. So to really ensure that the energy transition 100% contributes to our climate goals, it's important that the materials that contribute to that energy transition are low carbon as well. And then there's a range of other transition risks and opportunities around the infographic in the middle. And I'll start at the top left, and that is that there's increasing regulatory and policy pressure on all sectors, but mining as well. So here in South Africa, we have a carbon tax. There's also the climate change bill that's going to be introducing firm level carbon budgets. And as I'm sure you're aware, the European Union has recently introduced a carbon border adjustment mechanism, which is effectively an import tariff based on the carbon intensity of goods that are imported to the European Union. And these policy and regulatory measures can reduce a miner's international competitiveness, or indeed domestic competitiveness as well, and increase tax liabilities and costs. On the top right-hand side, there's increasing investor expectations for mining companies to set decarbonisation targets and establish credible decarbonisation strategies. And in the absence of those strategies, it can put your access to capital and finance at risk. Customers are also increasingly demanding low carbon materials. And in the absence of clear decarbonisation plans or ambition, including adaptation, it can put your social license to operate at risk as well. And then lastly, decarbonisation is increasingly becoming feasible and affordable and provides a number of benefits. Yes, there are some high upfront capital requirements with some of these low carbon technologies like solar panels, for example, but they can go a long way in reducing operational expenditure and help build resilience to international oil prices as we see at the moment. So all in all, I think, a number of transition risks that are facing the mining sector, and decarbonizing mining operations can avoid some of those transition risks, but likewise a number of opportunities that come hand in hand with decarbonizing. So now moving on to the decarbonization mitigation hierarchy. The hierarchy is informed by a number of best practice standards, such as the ISO, IFRS, and the SBTI, and it's effectively broken down into 5 stages, and the idea is to progress from the first one down, so starting with measurement down to offsets. At the top, we have measure. So the first step is to understand where your emissions hotspots are by conducting footprinting, looking at what your scope 1, your scope 2, and your scope 3 emissions are, to identify hotspots and to be able to prioritize where you need to deploy low carbon technology to start reducing those emissions across your hotspots. The next one is avoid, so implement strategies to prevent or avoid generating greenhouse gas emissions to begin with. The third level is to reduce, so enhance operational efficiency to lower the amount of greenhouse gas emissions you are producing. The fourth level is then to replace. So here we're looking at replacing carbon intensive options with lower carbon alternatives to decrease your overall emissions. The last step in the mitigation hierarchy is then to offset or neutralize any remaining hard to abate or unavoidable emissions. Due to various reasons, either from a sort of physical or chemical perspective, some greenhouse gas emissions are just unavoidable. Likewise, from an economic perspective, it might just be too expensive, or the technology might not exist to avoid, reduce, or replace those greenhouse gas emissions, in which case you would rely on carbon offsets or carbon removals to try and sequester greenhouse gas emissions from the atmosphere and balance any remaining emissions that you generate with those removals, so you get to either carbon neutrality or net zero. On this slide, we try to explain how one would put that mitigation hierarchy into practice. And in a nutshell, the mitigation hierarchy emphasizes that companies should prioritize emissions minimization, so getting your all emissions that are avoidable, get them out the system, and really make sure you're left with only those hard to abate residual emissions. So looking at the graph on the right, you would start by measuring your greenhouse gas emissions and establishing a baseline, which would be that first bar in the bar graph. You would then implement the next 3 phases of the mitigation hierarchy: avoid, reduce, replace, to bring those bars down each year and effectively reducing your overall gross emissions. So those dark blue bars, you can see as they come down over time, you would then get to your target year, so that very last bar with the blue diamond. And at the bottom below the graph, you can see the purple bars slowly starting to increase, and that is where your carbon offsets would then come in. You can see initially the purple bars below the graph don't match the dark blue bars above until that final year or your target year, where you're left with only hard to abate emissions and you're balancing those with carbon offsets. And then real quickly, maybe just to explain some nuances between the terms carbon neutrality and net zero. They are at a high level aiming to achieve the same outcome, and that is to balance any new emissions with removals or offsets such that there are no new emissions in the atmosphere, but with some nuances. So on the carbon neutral side of things, it is mandatory for scope 1 and 2 emission sources. Scope 3 emissions are optional under kind of carbon neutral approaches. Carbon neutrality doesn't have a set temperature pathway and doesn't mandate a certain amount of emissions reductions. So you could reduce your emissions by 40%, by 60%, and then offset the remaining either 40% or 50%, whatever's left, and you would be able to achieve carbon neutrality. And the standards that align with carbon neutrality are the PAS 2060 ones. That's a little bit different to net zero, which is defined as having deeper emissions cuts and explicitly following the mitigation hierarchy. For net zero, you need to include all emissions scopes, so scope 1, 2, and 3. And generally speaking, you would be required to reduce absolute emissions by at least 90% by either 2040 or 2050. And that is explicitly aligned to the 1.5 degree temperature target. You are then allowed to use high quality carbon removal offsets to neutralize the remaining 10% of your emissions under a net zero pathway. And standards that align with this definition are the SBTi and ISO. So that's it from me for now. I will hand over to James, who will take us through each of the next phases of the mitigation hierarchy and provide a few practical examples within each of the phases. Thanks. Over to you, James.
Great. Thanks so much, Reinhard, and welcome everybody. So yeah, kicking off where Reinhard left, the first step on the mitigation hierarchy is, of course, to measure, and to measure is to know. And so without being able to understand exactly what your baseline scenario is, what your current emissions are, and where they come from, and what the hotspots are, it's very difficult to build a decarbonisation strategy that is both structured in its approach and very targeted. So in terms of measurement, there's some jargon that gets thrown around, such as scope 1, 2, and 3 emissions. So scope 1, 2, and 3 is terminology that was coined by the Greenhouse Gas Protocol, and that effectively divides emissions created by an operation into either direct or indirect emissions, and a small nuance in the indirect emissions that I'll touch on now. Direct emissions are those emissions which are directly impacted by the company or operations activities. So if operations increase, scope 1 emissions directly increase. Scope 2 and 3 are indirect, meaning that the operations or the scale of operations not directly correlated with the amount of emissions, but there is a dependency because the activity requires certain inputs that result in those emissions. So scope 2 emissions are those which are as a result of the purchased electricity, or mostly in South Africa, mostly just electricity, but in other parts of the world, steam, heating, and cooling. So that's input energy which is necessary for the operational company to operate, but doesn't necessarily produce emissions at the point of consumption, but at the point of production. So in South Africa, that would be from Eskom, and as we know, in South Africa, the majority of electricity comes from coal. And then lastly is Scope 3. Scope 3 is a little bit more complicated, but it's divided into either upstream or downstream emissions. And that is the emissions that are a result of all the input materials or input processes that go into your operations, as well as the downstream processes that are as a result of you producing the output that your company or operation produces. So some examples of that would be the emissions related to the goods and services that you render, the fuel and energy that you purchase. So for example, there's some piped gas in South Africa, the emissions around piped gas, business travel, employee commuting, etc. And then downstream of your operation would be the logistics and value chain of your product going to the market. And also one really important one, which is now becoming more and more an increasingly important topic, is the end of life treatment of the product that you produce. And so end user responsibility is becoming a more and more important topic. But in a nutshell, it is the sum of all the emissions that are produced as a result of your operation or company's activity. You can go to the next slide there. No, thanks so much. So once you understand what your current baseline is, or your current emissions, and you have your sort of business as usual type scenario, the next thing to do is to set targets for yourself. And the targets are typically separated into a long-term target and a near-term target. So the near-term targets are normally a 5 to 10-year timeline on them, and those are emissions reduction targets, typically, focusing on the easier to achieve sort of quick wins, such as, or maybe I'll go into a bit more detail later on, but maybe your 30 to 50% decarbonisation range. The longer term targets are your more aspirational targets. You're looking at a 2050, 2040 timeline, and those are targets where you commit to achieving this concept of net zero by a certain date. And so you'll see now as we go through the mitigation hierarchy what it takes to achieve that, and why it is important for companies one by one are now setting these long-term targets. And then in terms of pathways you can follow to achieve these targets, there's different targets that can be set. The first is an absolute target. So an absolute target is, if you take your baseline emissions, let's say hypothetically company A has 30,000 tons CO2 equivalent per year as their emissions profile, an absolute target would be a percentage reduction on that amount. And that differs to an intensity target, whereas an intensity target is an emissions profile, emissions value that is relative to the output metric, or the output of that particular production. So for example, in the mining industry, a common intensity metric is ton CO2 equivalent per ton of copper produced. Where that is an important distinction between absolute and intensity targets. Absolute targets don't necessarily increase or decrease with a change in production. So if you were to, let's say, rather trivially say an absolute target can be achieved by ramping down production, whereas an intensity target cannot be achieved by ramping down production, because it's always measured as against some sort of output material. So if you decrease your production, your intensity does not get affected. Yes, in simple terms. And then lastly is science-based targets. So it is targets that are progressively implemented, aligned with the 1.5 degree Celsius temperature goal. All right, great. So now the next step down the line is avoid. So now we've understood what our emissions are. We've set ourselves a target. The next is to avoid. you'll see that as we go down the mitigation hierarchy, there's a very deliberate reason why each of these steps are there. As you go down the mitigation hierarchy, the effort and cost that you're going to have to expend to achieve the reductions is going to increase. And so therefore, as you go up the mitigation hierarchy, your priority must be higher. So before going further, we first want to see what is it that we're doing, or what are we planning to do, and what changes can we make to avoid emissions. You can go to the next slide, Ronald. Thanks. So a little analogy to use to relate this to a mining operation would be, you don't want to mine waste material. You want to mine only the ore body. So that means that you, taking that back to emissions, is that if you were to plan any kind of change in your operation that's going to affect the way that you do business, you can make those changes initially to plan and design and change your operating model to prevent emissions from ever having been created. So an example of that would be, before expanding the diesel haulage capacity, a mine could consider whether the plan can change to reduce emissions before they occur. And what that means is you avoid locking in years of additional energy consumption and the resulted emissions before they even occur. And so this typically results in your lowest abatement cost. And so a little side note here, what does abatement mean? So it's abatement cost mean it's your cost per ton of CO2 that you reduce. And so avoiding is more often than not one of the cheapest ways to avoid future emissions, because no capital has yet been allocated or spent. So it's easier to change something before decisions are made rather than after they're being made. Thanks. All right, so now that after we've gone and we've looked at our plan and we've got a good understanding of our operations and we've avoided emissions wherever we can, the next is to say, okay, what can we reduce? What are we currently doing and how can we reduce it? So that looks at enhancing our operational efficiency and to lower the amount of GHG emissions produced, given that processes are already underway and those cannot be fundamentally changed. So the analogy, once again, to improve the recovery process. So if there was something that you could do in a process, let's say at the concentrator or something like that, to improve the amount of mineral that you extract per ton of ore that you mine, you would do it. The same goes for emissions. So it's once the unavoidable activities are understood, the next step is to reduce our emissions intensity. A practical example of this would be a mine reduces its diesel use through implementing improved haulage technologies, electric drills, better fleet dispatch, reduced idling, etc. Anything that doesn't fundamentally change the activity, but reduces the amount of input energy required and therefore the amount of emissions produced. So both avoid and reduce are demand reduction activities. And those are fundamental to the next steps. If you can get your emissions as low as possible without having to make major changes, that puts you in a good stead for being able to take the next steps down the mitigation hierarchy. The next step is then, of course, replace. So we've done what we can, we've avoided the emissions as we can, and we're running as efficiently as possible. The next thing is to look at replacements. So that's the replacement of your input energy sources with low carbon alternatives. So sometimes, as I said, sometimes the efficiency improvements are not enough. You get to a point where you're running with the current technology that you've got as the best that you can. The next step is to fuel switch. So that could be fuel switching, electrification, renewable heat, green hydrogen, and in a really interesting case, like alternative reductants in the beneficiation process. So an example of that is a smelter or processing facility uses heavy fuel oil or coal-based thermal energy, and they choose to replace that with biomass, biogas, biomethane, electricity, or any other lower carbon alternative, where obviously is technically and commercially viable. Some commonplace examples of that is internal combustion engine vehicles being replaced with electric vehicles, commonly referred to as electrification. And then also is diesel generators being replaced with solar, photovoltaics, and batteries. All right, so now we understood our baseline. We've set ourselves some targets. We've avoided the emissions in our plan as best we can. We've improved efficiency, and we've replaced every other fossil fuel or high carbon energy source with a low carbon alternative. What next? So typically by doing these first four steps, you can achieve that 80 to 90% decarbonisation. But it's right at the end, what can you do to offset the last bit? And of course, that is offsetting. So that's investing in carbon offsets, which neutralize that residual emissions that you cannot get rid of. So yeah, I mean, as I've said, it's that last little bit that remains that we're trying to target. And some important aspects around offsetting that I think in the past, and it's part of the reason why we've seen the shift from a carbon neutrality to a net zero, is that offsets have been used in the past as sort of a get out of jail free card, is that you can offset any emission at any point with an offset. So offsets should only really be used, should not be used, sorry, to delay real mitigation. They should be done to just close that last little gap that's unavoidable or not practical to avoid. Emissions offsets, also known as carbon credits, and they are issued under crediting programs such as Gold Standard or Vera. There's a lot more coming out. Standards are popping up everywhere, and it's really great. It's a good movement in the industry. And they're recorded on public registries where they can be bought, transferred, or retired. And retired means here, if you purchase a carbon credit and you choose to retire it, you mean that you are offsetting an emission that you've created with an offset. And so each carbon credit represents 1 ton of CO2 that has been offset. An important thing to note is that not all offsets are equal. Offsets can be separated into 2 general categories. The one is an avoidance or reduction credit, and the other is a carbon removal credit. So an avoidance or reduction credit is a credit that the activity that generated that credit prevented emissions from being produced. So some examples of that are quite commonly available in the market are clean cooking, where interventions are done to reduce emissions at a household level. Methane capture, so there's fugitive methane emissions, capturing that and avoiding that from going into the atmosphere, or avoided deforestation. That differs from a removal credit. A removal credit is physically taking carbon dioxide out of the atmosphere and storing it. Another example, or some practical examples of that, is afforestation, biochar, enhanced weathering, or direct air capture. So it's basically activities that take CO2 that's in the atmosphere and take it out of the atmosphere. Many carbon credits are produced through activities that do much more than just reduce or remove emissions from the atmosphere, and they provide several social and environmental co-benefits that contribute towards achieving sustainable development goals. It's really important to understand that offsets or projects that produce offsets are not necessarily just doing that as its only activity. And this is where this concept of additionality comes in, which I'll go through in a moment. All right, so now you're at the later stages of your decarbonisation journey, and you're looking at purchasing offsets. It's important to understand what makes an offset a high quality offset. And what we refer to as a high quality offset is some offset which is both additional and has high integrity. So additionality means that if it were not for the production of the offset, which enables the financing of the activity, that reduction or removal would not have happened. So the simple question is, did this reduction or removal happen because of the carbon credit, or would it have happened anyway? So it's important to understand that carbon credits should only be generated at activities that are funded or significantly funded by the generation of carbon credits. So there's that additional financing or additional enabling environment that can create these removals reductions. And then the second is integrity. Integrity meaning that these carbon credits are real, they actually did happen, and that they can be audited and rigorously defended. So if you're purchasing these credits, is the claim that we have reduced one ton of CO2 and therefore produced a credit, is it real? Can we go in and certify that? And the combination of those two really gives you a high quality credit, which you can then use to offset your emissions. Great. Thanks so much. I'll hand it over back to Reinhard.
Thanks very much, James. And just to summarize and to round off the presentation before we move into the Q&A, a credible decarbonisation strategy follows the mitigation hierarchy. So step number one is to measure your greenhouse gas emissions, set credible decarbonisation targets that are aligned to a 1.5 degree trajectory, and then to develop a bit of a strategy. So identifying where can you avoid emissions, where can you reduce emissions, and where do you need to substitute energy sources, implement those strategies, and then as a last resort, rely on carbon offsets to neutralize your last little bit of hard to abate or residual emissions. Remember that it's important to rely on credible carbon offsets before reaching net zero or carbon neutrality. But ideally, following this mitigation hierarchy and using offsets as a last resort is, I guess, an internationally recognized credible approach to decarbonizing business operations. So with that, I think I'll leave it there and open up to some questions and answers. Thanks very much, everybody.